Hello and welcome to another video. In this video, we're going to be doing meeting rooms 3. And in this problem, you're given an integer n and there are n rooms numbered from 0 to n-1. You're also given an array meetings where meetings has a start and end time. And so they tell you that the meeting will start at end and it will end right before this time. So if it starts at like 2, it ends at 7, the room will be available at 7. All the start values are unique. Meetings are allowed to or allocated 2 rooms in the following manner. Each meeting will take place in an unused room with the lowest number. If there are no available rooms, the meeting will be delayed until there's one that's free. And the delayed meeting should have the same duration as the original meeting. When a room becomes unused, meetings that have an earlier original start time should be given the room. Return the number of room that held the most meetings. If there's multiple, return the room with the lowest number. So they tell you like what a half closed interval is. And they have these examples. So they tell you like if you have 2 rooms, you have room 0 and room 1. So if a meeting goes from 0 to 10, in the beginning, room 0 is open. So room 0 will take this meeting and it will be available at 10. Then for this meeting, this room will take it. It will be available at 5. And then at 2, no room is available. So the first room available will be used and this room will be available first. So it will be available at 5 and it will span the same duration as this meeting. So it will go from 5 to 10. And then afterwards, you will take this room for the last meeting. And so we return 0 because both rooms are used twice. And the second example is kind of similar. This is the one we're going to go through in detail. But essentially, this type of problem falls into a bucket of problems that are called like process some tasks using some. So I think there's literally a problem called like process task using servers, but we can call it, process task using like available structure or something. And the basic idea for these problems is the way you want to have it is you want to have 2 data structures, and typically heaps are really good for this. So you want to have a heap that is available, room, servers, whatever it is, and then another heap that is used up, room, servers, and whatever. And this will work for the constraints because the meeting's length is 10 to the 5th, so we need like an n-log-n solution. So for every meeting, we can essentially use these 2 heaps. And so the idea of these 2 heaps is you have one heap with available rooms, and then whenever there's a meeting, because it's going to be a min heap, you can just, because we want to say like for all the available rooms, we want to take the one with the smallest number. The available rooms will just give us the smallest number because it's a min heap. And then every time a meeting starts, before actually doing the meeting, we want to take all the used up rooms and check, are any of them available now? And so the available rooms will be of the format just one number, where it'll be like I, where like it's the index of the room. But the used up rooms, we want to have them in a way where they are sorted by the time they are available. So we'll have like a time here and the room number. And then we can just check like if a meeting starts at some time, let's go to all the used up rooms and let's free up as many as we can. And then let's take the smallest available room that we have. So let's walk through this actual example, this example 2. So let's move this down, make it bigger, and walk through what it's going to look like. And there's going to be one more edge case, or not edge case, but one thing to handle is if your meeting starts, and we'll see this, and there are no available rooms, we'll see what to do there. So let's just start off with available rooms. So we'll call this like available. And by the way, so they wanted you to finally return the number of the room that held the most meetings. So that can easily be handled. You just make an array of length n, and then every time you use a room, you just increment that number at that index. So like as long as you can process these meetings well, this last part's pretty easy. So let's just walk through how this will work. So in the beginning, all rooms are available. So if we have 3 rooms, we have room 0, 1, 2. And let's go through these meetings. And used has no rooms as well, right? There's nothing. So for the first meeting, we want to just take the first available room that we have in our available rooms, which we have. These are both heaps. So we can easily be like, okay, this one's available. Let's take this. And then we are going to put it into the, let's actually make this a little bit bigger maybe. So let's put available here. Let's put used over here, make this bigger so we have space. So room 0 is available. So we're going to say, okay, let's just pop from the available rooms, whatever is the first room available. In this case, it's 0. Now, what we want to do is we want to figure out how long does it last. So it's available at 20, right? So it starts at 1, ends at 20. So we want to write in the used heap when it's available, and we want to sort by availability. So we're going to say, okay, it's available at 20, and it is room number 0. So we can sort this in a tuple of time available and the room. And we're going to mark that 0 was used once here. And then let's go to the next meeting. So we can delete this, go to the next meeting. So the next meeting is over here. And so this meeting starts at 2. Once again, we check, do we have an available room? Yes, we do. We have room 1. So that's the room we're going to use. So we're going to say room 1. It starts at 2, ends at 10. So this will be ready at 10. So we'll say it is ready at 10. And it is room 1. So room 1 was used once. And now it's no longer available. Then we go to the next meeting. So here, this meeting starts at 3, ends at 5. We have only one room left. So this room will start at 3, end at 5. So it'll be available at 5. So we'll say it's available at 5, and it is room 2. And now we have no free rooms. So 2 is used once. And by the way, so I forgot to mention this, but at the start of every meeting, we'll free up everything available. So in this case, there is nothing available because these all end at 20, 10, and 5. So there's nothing available yet. So this is the edge case I was talking about where you get to a meeting and you have no available rooms. In that case, because this used is a min heap, we're guaranteed that if we just pop the first available room from the min heap, like the smallest one, that's going to guaranteed give us our best one. Because because a min heap, it's sorted by this value, right? Availability. And if there's a tie, like let's say both of these rooms are available at 5, then the first value will have the smallest room number. So it will always give you the smallest room number that's available first. So in this case, if we pop from this used room, if this is a min heap, we're going to pop this value here. And so now notice that this room is available at 5 and this meeting starts at 4. So what they said is if there's a delay, you have to still have that room take up the same amount of time that the meeting would have. So this meeting takes 5 seconds. We can just get like a difference to figure this out. And we can say if there are no available rooms, let's pop a used room and let's put it back in. And its available time will just be whenever it's available plus this meeting duration. So this meeting duration is 5. This room is available at 5. So we can pop it and use it again. And now it's available at 10. And we'll say room 2 is used here. And that's how we can handle having no available rooms. Now you can pop multiple. But like I said, it doesn't really matter because you just want the first one. And then for the next meeting, you'll just like pop the next one. So either one's fine. So now we go over here. And this is kind of the same kind of thing, right? This meeting starts at 6. We don't have any rooms that are available at 6. But if we just pop the first one available, it's going to be this one. Because these both have a 10, but this is a smaller second value. So 1 will be used again. And when is this available? So this meeting lasts 2 seconds, so this will be available at 12. And finally, you just return the number that has the biggest value with the smallest index. So because there's a tie, we should return 1. Yeah. So room 0 held 1 meeting, room 1 held 2, and room 2 held 2. So we want to return 1. So that's the basic idea. You just use 2 heaps, and you want to have available and use meetings. And then every time there's a new meeting, just free up everything you can, and then just take the smallest available one. And this is pretty common for other things. Like I said, the process task using servers, you might get asked instead of this, like a meeting might have a constant time or some other way of writing this, but it kind of boils down to the same thing. You have some tasks and you have some available things. Like instead of this, this also you might have another array of like times when your like server or room first becomes available and so on. And so there's like a slight modification to this to make it happen. But essentially, they all use 2 heaps. So let's take a look at the code. So this is just going to be like our output room. So for every room, we're just going to write down how much it was used. That'll all start with 0. Then we have our available rooms, which is just going to be 0 to n minus 1. And the nice thing is, so a heap in Python isn't really a heap. Like it's basically an array, and you just call heapify to make it a heap. But because this is already sorted increasing, this will already have heap structure. So you don't need to heapify here. Where in like Java or something, you would have to make like a min heap. So you can't do this. But you don't need to heapify something that's already sorted. So a small tip there. So our used rooms is nothing. We need to sort the meetings also because they're not guaranteed in order of start time. Like these examples happen to have it, but it's not necessarily the case. Like they can be all over the place. So we're going to sort our meetings. And then finally, for every meeting, we'll take us the start and the end time. And we'll just check while we have used rooms and the first available room ends before the start time or at the start time, we'll free it up and put it into our available rooms, right? So we just pop it and put it into our available rooms. Then if we have no available rooms after we did that, we will just pop the smallest room from our used rooms, and that's going to guarantee to be the best one because it's sorted by time and room. And if the time is tied, it will give you the smallest room. So then we get it, and then we put it back in, and the time is going to be the time that it was free plus the duration of this meeting, right? The end minus start time of the meeting. So we just put it back in. Otherwise, we just take the available room with the smallest index and do the same thing. We put it into the used rooms with the start time of the meeting. So if we did have a room available exactly when the meeting started, then it will end at I guess technically you don't even need this. I think this can just be end because it's just basically available. Like it was available right when the meeting started, so it'll be available right when the meeting ends. But these are the ones that are delayed. The ones with delayed start at this time where it was first available, and then you have to add the difference. So we can do it this way. Then we just increment whatever room we used, and then at the end we just loop through all of our rooms and return the one with the biggest index, basically. So we can run that. It should be good. Submit. Yeah. And this is about as good as it gets. I think when I was running it a bunch of times, it was on like the 90th percentile or something. But this format is going to be the same for like all these problems where you have some tasks and some things that you can use to process these tasks. You have 2 heaps. You go through all of your things that you need to process. First, you clear out everything that's used up. You put it into available. And then you do this jump where if there's nothing available, just jump to where the meeting starts. Like one thing you could do that would be slower is instead of going through meetings, you could just start with like times. So you could start at like time 1. If nothing's available, let's just go to time 2. If nothing's available, let's go to time 3. But that's going to be slower and it will not pass. I think for this problem it would pass, but for other problems it might not pass. Like let's say your times here can be like 10 to the 9th. And if you're first, like let's say you only have one room and you have a meeting that starts at like 1 and ends at like 10 to the 9th or something. And then you have another meeting that starts at like 10 to the 9th, and then ends at like 10 to the 9th plus 1. Like using a time, you would have to be like, okay, at 1 second, I use this room. And then at 2 seconds, I have nothing available. 3 seconds, I have nothing available. So you're basically looping to 10 to the 9th. So that's why the shortcut is a lot better. You just go to the next meeting that starts and you just say like, okay, I'm not going to go time. I'm going to go to the next meeting that starts and I'm just going to jumpstart my time to that. So I don't need to go like 1 second at a time or anything. This will be a lot faster. Yeah, so let's go through the time and space for this one. So essentially for every meeting, it will require a room, and a room will basically get like heap popped and heap pushed or some kind of like, some kind of order of operations there, right? So clear up the rooms, you check if there's nothing available, otherwise you just use a normal room, and then you do something. So a lot of these problems are very similar, they just ask you slightly different stuff. So it's going to be n log n, where n is the length of the meetings, because for every meeting you will put a room into use and then you'll put it back. And yeah, and then this is of n space. So the most meetings you can have in a used or available, or the most rooms you can have in a used or available will just be like this n here. So actually small, so I think this was actually wrong. So n is the number of rooms. If m is the number of meetings, then it would be like this, m log n. For every meeting, you put a room in and out of the heap, but the heap can only have 100 rooms max. So it'll be m log n, and then the space will be O of n, where n is the number of rooms, not the meetings. Yeah. And yeah, I think that's all for this one. So it's definitely a pretty good one. I think I got asked basically a version of this on like a TikTok thing I did. So definitely good to know. I think it's a pretty good interview question. I wonder if we get asked. Let's see. Not that common. I think it's like a little difficult to be asked. And a lot of these things that asks you are kind of trivial. They just like have a known problem and add things that aren't super hard. Like this kind of thing is like, if you can just get through this simulation, like this part is pretty straightforward. So they have all this like unnecessary info, but the basic just like meetings and rooms should definitely, you should definitely know that one. So yeah, it's going to be all for this one. And if you like this one, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.